Hello students, in this video lecture we will discuss moment generating function, mean and the variance of Poisson distribution. So before we solve this problem, first we recollect what is Poisson distribution. The Poisson distribution is nothing but P of x equal to probability of capital X equal to small x, that is equal to e power minus lambda into lambda power x by x factorial. So here x varies from x equal to 0 to infinitive, which means x is nothing but countably infinite numbers and the lambda is nothing but Poisson distribution parameter. So we consider lambda value is strictly greater than 0. Okay, next we recollect what is moment generating function of a Poisson random variable capital X is nothing but mx of t equal to expected value of e power t capital X, that is equal to summation x equal to 0 to infinity e power tx p of x. So wherever capital X is there, we place capital X equal to small x. Why we consider x equal to 0 to infinity? So that is nothing but given probability mass function. Okay, why we consider discrete means Poisson distribution is nothing but it is generally discrete distributions. Okay, so solution, what is given? Poisson is given. What is Poisson distribution? Small p of x equal to probability of capital small x, that is equal to what? E power minus lambda by x factorial. X varies from what? 0, 1, 2, etc. What? Up to infinity. Okay, so this is given statement. Our given statement is what? Poisson distribution. What is step number one? Step number one is to find moment function of a Poisson random variable capital X. Okay, so moment generating function is nothing f of capital X. This what is the meaning of that capital X? Is nothing but Poisson random variable. Okay, so we know that the given distribution is what always it is a discrete distribution. That means, so this is called what? Discrete distribution. So we know this for moment generating function, right? So what is MGF formula? That is nothing but mx of t equal to what? Expected value of e power capital X, that is equal to summation e power t x p of x, wherever capital X, we place capital X equal to small x. Okay, so that is equal to, now substitute given function, that is nothing but given probability mass function. Okay, so therefore we get summation e power into e power minus lambda power x by x factorial. Okay, what is x varies from? X varies from 0 to 0. E power minus lambda is constant, so take outside equation, we get e power minus lambda summation x equal to 0 to infinity e power tx into lambda factorial. So coming to this equation, so here we see power x is there, here also power x is there, so that we're going to arrange power of x term separately. So we get e power minus lambda into summation x equal to 0 to infinity. We can write e power t x by x factorial. Now we are expanding the series, which means substitute x equal to 0, 1, 2, 3. So e power minus lambda into substitute x equal to 0 here. Anything power 0 is anything power 0 is 1, and also 0 factorial equal, that is also 1. So if you substitute x equal to 0, you get total value is 1. Substitute x equal to get numerator value e power t by 1 factorial. X equal to 2 lambda e power t whole square by 2 factorial plus etc. Okay. So now we have one formula is, what is exponential of e power x? Formula is 1 plus x by 1 factorial x square by 2 factorial plus etc. What is e power minus x? Formula is 1 minus x by 1 factorial x square 2 factorial minus etc. So here is what our series will be positive, and also what is our x value? Value is e power, what is our x value? Lambda e power t. So substitute in this equation, we get what? E power minus lambda into e power lambda e power t. Okay. So therefore, the moment generating Poisson distribution is what? Mx equal to e power minus lambda into e power lambda e power t. Okay. Third, moment generating function of a Poisson variable. So step number 2. What is step number 2? To find mean, right? What is mean formula? Mu equal to expected value of capital X, that is equal to what? Mx dash of t equal to what? 0. Okay, this is mean value formula. So now first we find mx dash of t. What is mean by mx dash of t? That is differentiate with respect to t in moment generating function. So we get, so what is mx of t value? E power minus lambda into e power lambda e power t. Okay, here function is there. So we consider e power minus lambda is what? Constant. Okay, you take outside e power minus lambda into, what is differentiation of e power ax? So differentiation of e power ax, nothing, e power ax into whatever you get function, same function you write, then once again differentiate with respect to x, you get a. So here e power minus lambda is constant, you take outside. So what is differentiation of e power ax? So e power ax. So we get e power lambda e power t. After that, once again differentiate with respect to t here. So you get what? Lambda into e power t. Okay. So here lambda is constant, you take outside. Okay, so we get remaining term is what? E power lambda e power t into e power minus lambda into mx dash of t value. Okay, right? So now substitute t equal to 0. So we get mean value. Okay, so what is mean formula? Mu equal to mx dash of t. Substitute wherever t equal to 0. So if we substitute t equal to 0 in this equation, we get lambda into e power lambda. Substitute t equal to 0 here, you get what? E power 0 is 1. So here you get 1 into e power minus lambda. Substitute t equal to 0 here, you get what? E power 0 equal to 1. So we know e power 0 equal to 1. Okay. Now you simplify this, lambda into e power lambda into e power minus. So here base is same. Okay, if base is same, we can add the powers, right? So if we get lambda into e power lambda minus e power, okay, e power, so if we simplify this, you get lambda into e power 0. What is e power 0? That is nothing but 1. So you get only lambda. Okay, so that get only lambda. Therefore, mu equal to what? Expected value of capital X, that is nothing but what? Lambda. Okay, so this is your mu value. So step number 3, to find variance. We know that what is variance formula? Variance of x equal to expected value of x square minus expected value of capital X whole square. Okay. So we know the e of x value. What is e of x value? That is lambda, right? So next we want to find e of x square value. Okay. That is our target. So now find e of x square value. What is e of x square value? That is nothing but mx double dash of t. Substitute t, t equal to 0. Okay, so we know m already, we m dash of t. Okay, so once again differentiate with respect to t. So we get mx double dash of t, right? So m mx dash of t, that is nothing but what? Lambda into e lambda into e power lambda power t into e power t. This is your, okay. So this is your m dash of t value. Okay. So here lambda e power lambda is constant. Okay. So here also e power t is there. Here also e power t is there. So we want to apply product rule. Okay. So you consider u. This is v. What is u v? U v dash, that is u into v dash plus v into u dash. We want to apply product rule. Okay. So lambda e power minus lambda into. So first you consider u as it is. What is your u value? E power lambda e power t into. What is differentiation of e power t? So you get e power t. Okay, plus next we consider v as it is. V value is e. What is differentiation of u? That is nothing but e power lambda e power t into lambda e power t. Okay, then substitute t equal to what? T equal to 0. So wherever t, so we substitute t equal to 0, right? So here lambda e power minus lambda is constant, take outside. If we substitute t equal to 0 here, e power 0 is 1. So we get e power lambda plus substitute t equal to 0 here, e power 0 is 1. So here we get what? E power lambda into, right? So if you multiply these two terms, lambda e power minus lambda plus lambda, which means if base is same, we can add the powers, we get this term. Coming to second one, lambda square into e power minus lambda plus lambda. So what is e power 0? E power 0 is 1, right? So we get here lambda into e power 0, lambda square into e power 0. So we know 1. So you get what? Lambda plus lambda square. This is nothing but what? E of x square. That means expected value of a Poisson random variable capital X square equal to lambda into lambda square, right? So now substitute E of x square value, E of x value in variance formula. Okay, right? So what is variance formula? We know that variance of capital X equal to what? X square E of x whole square. So substitute here. E of x square is nothing but we get lambda plus lambda square minus what is E of x value? That is lambda whole square. Okay, one. So if we simplify this, you get lambda plus lambda square plus minus are getting cancelled. You get only okay. So here also variance of x equal to what? Lambda. So therefore, hence what is your moment generating function of a Poisson random variable that is equal to what? E power minus lambda, e power lambda into e power t. Okay. What mu value? Mu is nothing but mean value, that is expected value equal to lambda, comma. What is variance value? Variance, it is denoted by sigma square, that is equal to what? Variance of x, that is equal to lambda. So here you see mean value, variance value, both are equal, same value. That means what? Lambda value. Okay. And standard deviation. Standard deviation is nothing but it is denoted by sigma. Sigma equal to what? Square root of variance of x is equal to what? You get answer is square root of lambda. Okay. So I hope you are enjoying this session.